In this lesson we're going to look at the transition elements and look at how they compare with the groups 1 to 8 elements that we've already looked at. First of all, let's identify the transition elements, and these are the ones in this block here, and they're called transition elements because they show gradually changing properties, both physical and chemical, as you move from the group 2 elements through to the group 3 elements. So what we're going to discuss here in this lesson are the key bullet point characteristics of these elements. So the first thing we're going to say is that they are all very good conductors of heat and electricity, and as is the case with all of these bullet points, there is always a variation between extremes, but we're talking about really with respect to the other elements in the periodic table. Okay, so as a general rule they are very good conductors of both heat and electricity. Now these two things go together because the mechanisms in which heat and electricity are conducted through a material really depend on the free electrons that are present. Okay, so these provide a whole lot of free valency electrons which enable the conduction of heat and electricity. Now within each bullet point I'll try and give some good examples of this. Well, we know that copper, silver and gold, there's a little mini trend there, all exhibit very good conducting properties. So the next key factor is they all tend to have high melting points. Now as a general rule the melting points tend to increase as you move down the transition group, although there are some exceptions to the rule. For example, remembering that mercury down here is actually a liquid at room temperature, and the melting point of copper is higher than that of silver or gold, but as a general rule in the rest the melting point tends to increase as we move down. So a good example of materials with a very high melting point is wolfram or tungsten, and that's used for light bulb filament. So that's got a melting point of about 3414 degrees Celsius, very high melting point for tungsten. Now in addition to having high melting points, they tend to be quite hard compared with the other elements. So hardness is the ability for one element to scratch the surface of another. So within this transition group we'll find that the hardest metal is chromium. It's not the hardest element. Remember that diamonds, that's an allotrope of carbon, is actually the hardest material known, but chromium is pretty tough stuff too. Fourth bullet point is that they all have relatively high densities. Again, as with the melting points, the densities tend to increase as you move down the transition block. Alright, so we'll find that the metal or the material with the highest density is in fact osmium. That has a density of 22.6 grams per cubic centimetre. So a cubic centimetre of osmium is going to feel pretty heavy. Okay, so we've got 4 bullet point characteristics for physical properties. They're good conductors, high melting points, they're hard, and they have high densities. Okay, so those are the key physical characteristics of the transition metals. Let's just have a look at their chemical characteristics. Okay, we'll put those over this side. Okay, so the first point is they tend to be less reactive than the metals in the other groups. That's groups 1, 2 and 3. That's the first point. The second point is that their compounds tend to be of different colours. For example, you've got sort of bluish turquoisey colour for copper compounds, and then iron 2 compounds can be a sort of greenish light green colour, and cobalt chloride for example has a reddish violet colour. So you get different colours in the transition elements, whereas in the group 1, group 2, group 3 metals, well, their compounds are all kind of whitish, they're non-coloured. Right, so we have coloured compounds. And the third bullet point is that the transition metals tend to have multiple valences. Those are also known as oxidation numbers. For example, copper can have an oxidation number of +1 or +2. Iron can have an oxidation number of +2 or +3. So let's just make a note of that. Let's put +1, +2 for copper, and +2, +3 for iron, and chromium can have oxidation states of +3 and +6. Those are the common oxidation states of chromium, but it can also have oxidation states of +1, +4 and +5. But for your GCSE and IGCSE exam, it's really important to remember the oxidation states for iron and copper.